Alright guys, we're going to reverse all the way to section 2.5 to discuss some basic compound inequalities. That word compound means two inequalities are involved. So if you look at A through D, we'll just do two of them. We'll do A and C. There is a graphed inequality. We don't know what it is yet, but it's shading in between 2 points rather than what we used to do, which is shading to just one side. So let's look at part A. Let's write two inequalities for this shaded interval. To do that, we're going to ignore the right side first and pretend that what we see right now is just this inequality, all numbers bigger than -6. So to describe that, we would write x is greater than or equal to -6. And now we're going to look at the right side of the inequality. So if we were just focused on the right, we have all numbers less than 3, not including 3. So x is less than 3. Okay? Now these can be rewritten into one inequality, and you guys saw this with domain and range the other day. We can rewrite this so that the lowest numbers on the left, the highest numbers on the left, and we write it as x is between these two values. Just make sure you match where the inequality symbol should go. So here we have x being greater than or equal to x being greater than or equal to -6, and on the other side it's strictly less than 3. And that would be the combination of both inequalities, which is how you write any inequality that uses an intersection, meaning an inequality where you see 2 points and shading going on in between. The word "and" will be used to describe those inequalities separately, and we can combine them like so. Let's try C. If we only focus on the left side of C, we have the inequality x is greater than or equal to -4. And now we look at the right, x is less than or equal to 5. When we combine these two, we write the smaller number on the left, the larger number on the right, and match up the inequality symbols with the variable in the middle. Okay? Now we're going to look at a different type of compound inequality that cannot be combined to be rewritten like this. We leave them written separately and we use the word "or." Anytime the inequalities face different directions, we use the word "or" to connect the inequalities. And we write them as we see them, literally just with the word "or" in between. So over here, we have x is less than or equal to 6. On the right side, we have, so make sure you use the word "or," x is greater than 3. And that's it for these. Let's look at C. The left inequality says x is less than or equal to -4. The right side inequality says x is bigger than, greater than, or equal to 5. And make sure you write the word "or" down. So to summarize writing, you can use the word "and" when you have shading going on in between, but we know we can combine them to look like this. And when we have inequalities facing opposite direction, we use the word "or." All right, so now we're going to solve some of these compound inequalities. Anytime you have an expression in between two numbers, we're looking at the compound inequality that refers to "and," where you shade in between values. But because x is not alone in the middle, we want to solve for x being alone in the middle. So I'm going to show you two ways. The first method just requires you to get x alone in the middle. So in this case, we have a -2. Just like you would in an inequality, we would want to add 2 to both sides. But now we have 3 sides. We have the middle, the right, and the left. And when we do that, the 2's in the middle cancel, and we're left with x is between 3 plus 2 is 5. And on the left, we have negative 4 plus 2, which is negative 2. Whoops, don't forget your inequality symbols. The other way to do that, and I'll show you the method on the same problem, is to rewrite the inequality twice. So the first inequality we have would be negative 4 is less than x minus 2. And then the rightmost inequality we have is x minus 2 is less than 3. And we would solve both of those separately. Make sure to always include the middle in the inequalities you write. So on the left, you have to get x alone by adding 2 to both sides. So we'll get negative 2 is less than x. On the right side, when we get x alone, we get x is less than 5. Same answer here, but now we have to take one more step and rewrite the inequality. X is between 5 and negative 2. Okay, I'm going to erase so I can graph for us. When you graph a compound inequality, you want to put a point on the values they give you. So 1 on negative 2, 1 on 5. They are both open circles, and we shade in between. On the right side, I'm going to use the initial method I used, which is getting x alone in the middle. Our first step would be to subtract 1 from all three sides. So now we have negative 4 is less than negative 2x, which is less than or equal to 8. My last step here to get x alone is dividing by negative 2 to all three sides. Now be careful because the rule about dividing by a negative applies here. When you divide by a negative, these signs need to flip. So I have positive 2 is greater than x, which is greater than or equal to negative 4. Don't stop here. Rewrite the inequality so that the lowest numbers on the left bring over the inequality symbols and the highest numbers on the right. That's your final answer, and then you can go to graphing. The left negative 4 is a closed circle, the right 2 is an open circle, and we shade in between. An OR inequality is a little easier because all you have to do is focus on one side at a time. And then in the end, you want to put OR in between your answers. So on the left, we have the inequality 3y minus 5 is less than negative 8. So to do this problem, we can add 5 to both sides first. So we have 3y is less than negative 3. Last step, divide by 3 on both sides, and we get y is less than negative 1. On the right side, to get y alone, we start by adding 1 to both sides. Then we get 2y is greater than 6. Divide by 2 on both sides, and we get y is greater than 3. The last step would be to put the words OR in between your final answers, and there is no combining of an OR inequality. When you graph each one separately. So start with y is less than negative 1. Here's negative 1. Open circle, shade to the left because those are numbers less than negative 1. On the right, we have 3 and y is greater than 3. Also an open circle, shade to the right. An OR inequality will always have your graph pointing in different directions. Try these problems on your own. These two are the AND inequalities. The bottom two are OR inequalities. So try them on your own, pause the video, and check your work. All right, so here are your final answers. Both 3 and 4 should have been shading in between. And 5 and 6 are OR inequalities. The biggest thing I noticed was that there was a sign flip when I divided by -2 on the rightmost inequality. So you can pause, look through your work, and that's it for this lesson. We are going to apply this to domain and range because domains and ranges are usually written as single inequalities or compound inequalities, where we know we have values between two numbers or y values between two other numbers. So it's important to understand your compound inequalities for this reason. And then in Algebra 2, you'll deal more with the OR inequalities. So this was a good little intro. We'll have a small exit ticket on all of this. Not a big test on it though.